Alright, first lesson. Lesson 1, properties of exponents. So today we're going to be talking about exponents. We're going to review and apply the properties of exponents. This is something you learned ever since pre-algebra. You should have learned exponents, and we did it again in algebra, and we're going to review it right now one more time, okay? And we'll have more difficult problems here for algebra too. Here are the steps for today. First step, determine which properties can be applied from the inside. Apply the properties from the inside to the outside and simplify. Okay. Before we dive into them, let's do a review of these exponent properties. A to the 0 power. What's anything to the 0 power? What do you think? 0. Wrong. It is 1. Okay. Anything to the 0 power is 1. So write these down as I go, okay? Write down exponent review. Okay, turn to your neighbor, tell them A to the 0 power is 1. Okay, good. Alright, A to the negative n power is going to be, whenever you have anything negative powers, we don't really like those in math for now, so this is like saying A to the negative n power. How do we make anything a fraction? Put it over 1, right? So the trick to getting rid of an exponent or negative exponent is to just switch the base with the exponent, put it to the denominator, and all that's left there is what's in the numerator. Okay. Next is A to the first. Anything to the first power is itself. It's just A. Okay. So whenever we see even A by itself, we're assuming there's a little 1 above here. A to the first power is just A. Okay. Third power, this is the product power of, or product property of powers. So we have A to the m times A to the n. You want to recognize that these have the same base first, and when they do, when you have two separate exponents that are being multiplied, you just add the exponents together, A to the m plus n. Okay, this is the quotient property of powers. Same thing, except instead of a multiply sign in the middle, this fraction bar, what does the fraction bar represent? What operation? Division. A to the m divided by A to the n is equal to A to the m minus n. So you subtract. Next is the power property of exponents. AB to the nth power. Whenever you have an expression like this one, it says AB, it's like saying A times B, and we have an exponent on the outside, what we're going to do is distribute this exponent to the inside. So A to the n, or AB to the nth power is just like saying A to the nth times B to the nth. Okay. Same is true when you have a fraction. Remember, this fraction bar is divide. A divided by B, all to the nth power. We're going to distribute this n to the inside. Okay. And then the last one we have right here. When we have a power being raised by a power, you're going to multiply the power. So we have A to the m, all raised to the nth power. You're going to keep the same base of A, and then you're going to multiply m times n. So it's going to be A to the m times n. Okay? So these are a review. We've learned these since pre-algebra, so you should have memorized or remembered these since at least 7th or 8th grade, whenever you took pre-algebra. Okay, so why don't you turn to your neighbor, do a quick review, get to know them a little bit. Take turns. Maybe the first person goes, talks about this property, next person talks about the second one, third, fourth, and so forth until you're done. I'll give you 30 seconds. Ready? Go.
Yeah.
Okay, so we got two problems. So at this point, when I do the first two problems, you just watch. So pencils down right now, you just watch, because I want you to make sure you see any sort of skills or things that you might miss if you're writing at one point. So problem number 1, it says simplify. Look at the directions always. 1, it says 2 to the third raised to the second power. So you got 2 to the third raised to the second. It means we have a power being raised by a power. So if I looked back at my last screen, right here, I know this is the last property, right? So I'm going to just take this, take 2, keep my base, 3, and then multiply my exponents together. 3 times 2 is 6, so this is like saying 2 to the 6th power. And to the 6th you can work out if you like. When it's a power of 5 or more, I don't really expect you to work it out. But let's just do it anyways. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32, times 2 again is 64. So the answer here is 64. Okay. So what did I just do here? First thing I did, read the directions, of course, always, and just to simplify. So determine which property can be applied from the inside. I realized this is the power property, the last one that we talked about here at the bottom. Okay. I looked at my notes, right? And then I applied that property from the inside to the outside. So there's only, the inside here is 2 to the 3rd, raised to the 2nd, so I want to raise these two powers together, multiply them, and I simplify. Okay? Watch me do number 2. Looks more difficult, but we could do it, okay? So, first thing we want to do is we have negative k to the 4th raised to the 3rd, and then we have negative k to the 3rd times k squared. So the first thing we want to do is I notice that it's negative k to the 4th raised to the 3rd. This is a power property. I could start with little chunks, numerator first and then denominator separately, and then I'll bring it together. Okay, so I know this is the power property. I'm going to bring this down. It's going to be negative k to the 4 times 3 is 12 in the numerator, and then I'm going to work my denominator now. Okay. We have negative k to the 3rd times k squared. Okay. This is negative times a positive, still going to be a negative. And then we have, these are both the same bases. 3 times 2, this is the product property of power. So we got 3 times 2, or it's going to be 3 plus 2, is just 5. So it's going to be negative k to the 5th power. Okay. Now we have two bases that are the same that are getting divided. So it's negative k to the 12th minus negative k to the 5th. Okay, so we have the same base. When we have division side, we're going to subtract the exponent, so it's going to be 12 minus 5 is 7, so it's going to be negative k to the 7th power. And we're done. Okay, that one's the hard one, right? Okay, so this is the first one, this is the second one. So let's pause there. Fake out. Number 3. Okay. Number 3. So write it on your whiteboards. If you want this in your notes too, if you do it correctly, you could put it in your notes later after you get it right. Number 3. Negative 4 to the 3rd times negative 4 to the 3rd. And once you're done, please put box your answer on your whiteboard. We have two bases. The base here is negative 4 with parentheses around it. Since we are multiplying two of the same base and we have two exponents, we're going to add the exponents, so 3 plus 3 is 6. This is your final answer for number 3, okay? So if you didn't put parentheses around them, then it was incorrect. So why don't you take note of that? Because the base really is negative 4. We're going to talk about that a little bit later. Number 4, by yourselves. Ready, go. We got negative 4xy times xy. The coefficient in front of xy is a 1. We could assume it's a 1. What's the coefficient in front of xy? 1. So we can multiply our coefficients first. Negative 4 times 1 is negative 4. Then we have x times x, which is like saying x to the first times x to the first, which is x squared. And then we got y times y is like saying y to the first times y to the first, which is y squared. Okay, if you got it correct, give yourself a pat on the back. Continuing on, number 5. Okay, this one's getting a little bit harder. Number 5. Go. Before you erase it, check this out before you erase it. So, first thing you want to do is you'll notice that there's a negative sign here in front of the whole problem. So, whenever you have a negative, let's just assume that negative sign is just really in front of the numerator always, okay? So just move it up there. All I'm doing is just taking it from here and moving it up in my mind, okay? Always apply it to the numerator. Okay, so the coefficient in front of the numerator is a negative 3. The coefficient on the denominator is a 1. So first thing I want to do is figure out what's negative 3 divided by 1. And in my numerator, I'm going to still have negative 3, right? Because anything divided by 1 is itself. Then I focus on my a's together. We have a to the negative second divided by a to the negative second. Okay? That's like saying a to the negative 2 minus a negative 2. Nope. What's negative 2 minus the negative 2? 0, right? So it's like saying negative 3 to the a to the 0, right? Then we're going to focus on our b's. Got b to the negative 4th minus, or divided by b to the negative 3rd. Again, we're going to do b to the negative 4th minus a negative 3, which is like saying b to the negative 1st. We know that anything to the 0 power is 1, so it's saying 3 times 1 times b to the negative 1st, which is like saying negative 3 b to the negative 1st. We don't like negative exponents, so we're going to keep negative 3 in the numerator and have b to the 1st in the denominator. Since it's the 1, we just leave it alone. So that's your final answer. That's a harder one, right? I showed all the steps. This is showing your work, right? You could have done this in your head. I know once you get at it, you might be able to do it in your head, but it's so complicated you have to show your work. Okay? So once you write this one down in your notes, give you 30 seconds, and then you'll get to start your next problem, last problem. Alright. I did notice some of you got to this second to last step, which was really good. I was really impressed. However, you want to make sure you simplify to that negative 1st power. Alright, once you're ready, number 6 is up here, okay? Again, I'm going to give you the hint. When you see that negative sign in the side, remember to assume it's at the top, like so. Alright, for now I'm just going to leave it there. Okay, I'll get last one. So, first thing I would do is just move that negative sign to the top. Okay? Next thing I'm going to do is I'm going to work in chunks. Can I simplify my numerator at all? I asked myself that. No, it's already pretty much simplified. I can't really do anything else with that. Okay? The denominator, though, I can do some simplifying, and I got a couple of things. I got to work from the inside out. So, we got 2a to the 4th power raised to the 4th power. Before I even multiply this, I have to apply this powers property here. Okay, so that means that this 4 on the outside has to be distributed on the inside, and then again to the 2, right? So I'm going to bring down the rest of the problem first. We got negative a to the 3rd, my numerator, leave that alone. The denominator we have a to the 4th times, and then we're going to work this out. 2 to the 4th power. Okay, so 2 to the 4th is like 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So I have 16 now as my coefficient. And then we have a to the 4th raised to the 4th is a to the 16th power. That's my denominator so far. Okay. I know the coefficient in front right of here is a 1. Okay. So the denominator now I could combine these two terms together. So we have 1 times 16 is 16. A to the 4th times a to the 16th. We're going to add the exponents. It's going to be a to the 20th. And then I'm going to bring down my numerator. Don't forget about that numerator, negative a to the 3rd. The numerator is like saying negative 1, so negative 1 divided by 16. We're going to leave that negative sign there. We have a to the 3rd over a to the 20th. A to the 3rd divided by a to the 20th. We subtract, so it's going to be a to the negative 17th power. So we have negative a to the negative 17th power all over 16. Okay, we know we don't like negative exponents, so this is like saying negative 1 over 16a to the 17th power. So this is an answer. I'll also take the negative sign in the front of the whole fraction, which looks like this. It's the same answer, just a different way to look at it. Okay, these are both the same thing. I'm just moving that negative sign. Okay. Questions? Because we have a to the 3rd divided by a to the 20th. So what happens when you have the same base, but you are dividing the powers? You subtract. 3 minus 20 is negative 17. Okay. So one of the things, that's a good question. You have to be really quick on your integers, positives and negatives. We're in Algebra 2 now. I'm not going to be wasting time on basics, okay? So if you're not getting it, and it might seem like I'm going to be insensitive to that, it's not because I'm insensitive. I want you to succeed, but I want you to know that that elementary stuff is really unimportant right now. If you're not getting it, then you need to come out of your way to talk to me and figure out a way to catch up, okay? We got one more question. Look at this answer right here. Let's focus right here on here and also our answer right here. What could I have done from here to here? What strategy could I have done? Raise your hand if you could predict a strategy I could use here. Yeah, Brianna.
Just take the 3a, or minus the 820.
Yeah, there's 3 a's on the top, right? A to the 3 on the top. This one has 20, so take the smaller one, a to the third. Let's just cancel that out. And then let's take out 3 from the bottom. 20 minus 3 is 17, right? Did y'all see that? So what's the coefficient here? -1, right? 16a to the 17th. So you don't have to do this middle step, but whatever's easiest for you, okay? Whatever gets you to the right answer. That's what I care about. Okay? And that's it. That concludes our lesson. I want you to answer these questions now. We want to close. So what did we learn? Think about what the objective was. Talk to your neighbor, then switch or discuss with each other. How do we do that? Discuss the steps. Okay. How does this fit in math? Exponents. Talk about that. Think about that. And how might we use this in real life? Maybe the concept. What is the concept we talked about? How might we use that concept? Okay. Ready, set, go.